Hey guys, back with another video. So what you're looking at is a prototype of an AI automotive cybersecurity incident and compliance assistant, a database-backed Python tool designed to organize and query cybersecurity incidents across vehicle platforms, ECU zones, connectivity paths, evidence records, and compliance controls. The problem this tool addresses is that incident data is often scattered across different systems. VIN records, Para notes, diagnostic logs, mitigation actions, and evidence references are not useful if they are disconnected. This project creates a structured foundation to bring that information together. Here's the project. This is the project folder. Starting with the schema.sql, which we have here. The schema defines the database tables, constraints, and relationships. C.py rebuilds the database and loads sample automotive cybersecurity incident data. The data folder, which is here, holds the project.db, which is the live SQLite database file. Project.db is not meant to open like a normal text or Python file because it's a binary SQLite database file. I do not edit it directly. Instead, c.py populates it, and schema.sql defines the structure, and db.py retrieves the data through SQL queries. db.py is the main focus because it separates the database logic from the interface. The docs folder also includes db access notes.md, which documents the database functions. Going back to schema. The schema includes tables for vehicles, incidents, risk assessments, controls, evidence, mitigation actions, and relationship mapping. The vehicle table stores VIN, make, model year, ECU zone, and connectivity type. The incidents table stores the attack vector, affected component, severity, status, and description. One important design decision is the risk score field. It is generated directly in SQL as likelihood times impact. That means that the database calculates risk consistently instead of relying on Python to calculate it later. Now open up db.py. At the top, database path points to data folder project.db. The get connection function creates a reusable SQLite connection and enables foreign key support. The functions return pandas data frames, which is useful because Streamlit can display them directly later. Get all incidents retrieves incident records with vehicle content. Get incidents by severity uses a parameterized query with a question mark placeholder. This avoids unsafe SQL string formatting and helps reduce SQL injection risk. Get incidents with assets uses a join to connect incident with affected vehicle assets. Get incidents counts by severity uses group by and aggregation to summarize incidents by severity and average risk score. Get open mitigation shows unresolved mitigation actions. The AI support function is get incident evidence for AI. It retrieves incident details, vehicle context, terror notes, link controls, evidence records, compliance gaps, and mitigation summaries. That gives a future AI model grounded database evidence to summarize the incident or recommend next steps. Now I'm going to run through the terminal. First, I'm going to type python c.py. This rebuilds the SQLite database from the schema and loads the sample vehicle and incident records. Then I'm going to run python db.py. The output shows the required database access functions working, all incidents, the parameterized severity query, the join query with vehicle assets, the group by severity summary, the open mitigation, and the AI evidence query. This confirms that Python is connecting to SQLite, executing SQ queries, and returning structured results. In closing, this confirms the backend database access layer is working. The SQLite database rebuilds through c.py. The reusable functions are organized in db.py, and the required query types return structured data that a future Streamlit interface and AI features can use. This is an early stage prototype, but the architecture is real. The data model is production relevant, and the path from here to a deployable tool is clear. Thank you.